Hello and welcome to this Mastering the Machine Automation Academy webinar for the 12th of February 2022. Today's topic was PLC templates. What are they and how do they work? How can you build your own? And I did have a question also on encoders towards the end by one of the listeners. Hope you enjoy it. Hello everyone and welcome to this episode of Mastering the Machine from the Automation Academy. It is the 12th of February, about 10 a.m. in the morning Central Time, and I'm going a little bit old school here. I used to do a lot of presentations on PLC programming, simulations and things like that, and we're kind of going back and revisiting PLCs again, which is kind of where I started the Automation Academy at. And today, we're going to be talking about a project that I'm working on really for a class for NTH University, which I've mentioned a little bit about what that is before. For 2 weeks every month, I work for a company called Automation NTH, and they have a program where they train their interns and apprentices and even their engineers in PLC programming, and I kind of handle that part of it. And I'm basically, my title there is the lead trainer, but I also do a lot of development, as some of you know. I've written a few books on PLCs and industrial automation, things like that. So this all kind of goes hand in hand with that, working on this PLC template. Now, Automation NTH themselves has a PLC template. And what I'm doing is I'm modifying one of my PLC templates to kind of match theirs, because I'm teaching their interns, and their interns should be learning, of course, the way that Automation NTH does things rather than the way that I do things. So that's why I happen to be working on this particular PLC template. So it's going to be a kind of a hybrid between the template that they already have at Automation NTH and the template that I've had for many years. Little bit of the preliminary stuff here ahead of time. We'll go through the boring stuff. What is Mastering the Machine? In 2013, I created a document called Mastering the Machine that you can download at these two sites. If you're happening to see this on YouTube or a repeat, you can go to these sites and download that document. It's about procurement and specifications of machinery, and I created it right after I'd left a company called Wright Industries. So it's based a lot on how procurement went there. It's evolved into a training and automation website that I started a little over a year ago, called the Automation Academy. And the Automation Academy is a membership site, and I do these webinars as part of that. But there's all kinds of information in the Automation Academy, a lot of downloadable files. And this template, eventually, I'll probably put quite a bit of material from this template on the site. There is already a lot of PLC information on there. That's kind of where I started. The Automation Academy was just a place to keep a lot of my PLC training material. My training material is not quite as formal as some of the classes you've had. I tend to go to more advanced topics, which is what this is, right? So what we're going to be talking about today is definitely an advanced topic. So I'm assuming when we go through some of these things, well, let me cover this first. So this is another page I forgot was here. What is the Automation Academy? Again, training videos for Allen Bradley, Siemens, Omron. There's some job and aptitude assistance, systems integration, and more. A library, community with interest groups, and regular events like this. So that gets all the boring stuff out of the way. But so this is definitely an advanced topic. So in previous courses and things like that, I've talked about what some of these items are, like add-on instructions. For those of you who are Siemens people, an add-on instruction is almost exactly like a function block in Siemens, where you have some local variables and you do have permanent memory. So the difference in Siemens between a function and a function block is a function doesn't have permanent memory. You would have to use memory within the controller, whereas a function block, you can create memory in the form of a data block and assign it to a function block. An add-on instruction is kind of like that. It includes some permanent data built into it as a AOI UDT, user-defined tag. What is a UDT? It's a collection of data, and it's a collection of different kinds of data. So you can mix your bools and your reals and your integers and things like that all together. And so that's what a UDT is. What is an EDS file? For those of you who are in Siemens, it's the same thing as a GSD file, which is what you need to import to put a new device into your PLC. So in Allen Bradley, and that's what I'm doing today, is I'm going to be talking about the Allen Bradley template that I'm creating. They use EDS files, and that stands for electronic data sheet. An electronic data sheet is just a text file, but you need it if you want little icons to appear in your IO tree representing whatever object you want to communicate with. So if you're going to add something like a Cognex camera or robot, you would need the EDS file for that. Where do you get those EDS files? I've mentioned this before. You get them from the vendor of the equipment, not from Allen Bradley. You don't call Allen Bradley up and say, I want an EDS file for a FANUC robot. You won't be able to get one. So you have to go to the vendor of the robot or the vision system or the valve bank or whatever it is that you want. So a little bit about this. So I mentioned that I'm doing this in combination. I'm doing a lot of work for Automation NTH, and I am writing a new book. And some of you probably have been to the previous webinars, or you've seen them on YouTube, where I talked a little bit about that book. But the tail end of that book has a big troubleshooting section on this particular type of machine. This machine, you can see here, there's a base for the machine. It's just a machine base, and it has a robot on it, and it has a little transport system, and it has a couple elevators. It has a left elevator and a right elevator, and this basically circulates parts from this elevator to this elevator, and then the elevator goes down and it recirculates it on the bottom, brings it back up the other side. So it's like a continuous loop. You can take these bases and stick them all together, and that's what they do. This is called a flex base, but they build a couple of other types of bases called a fast base. And the fast base, you can stick them together to build a whole line of machines. And since I have this program, and they used part of their template to create this program, and then I also have a copy of their original template, which does not match this particular machine's program. It's really quite a mixture. And then, of course, like I said, I have my own template, and my template includes a different type of data and things like that that I would use in their PLCs. So let's talk a little bit about what a template is again. So a basic PLC program that serves as a starting point for a project. So what I'm going to be showing you here is a PLC program that has some pre-configured routines and things like that, some pre-configured tags, and I've already been importing some things into that program that a user would need. You have to be careful when you create a template not to put everything in there, because if you do, the program gets really, really heavy, and then you end up just having to delete a lot of things, and that can be difficult. When you delete something, you know, it has its own UDTs and its own AOIs, and the AOIs may depend on the UDTs. So you can't delete a UDT unless the tag that uses that UDT is already gone, right? So you have to delete all the tags first, and then you have to delete the UDTs. If you have AOIs in there, they can leave their own UDTs behind. So you really don't want to import a lot of things into the template that people are going to have to get rid of. That's kind of an important rule. So let's talk about kind of how I'm working on this particular template. Maybe I'll show you first the program that I'm working on that has a template in it. Well, actually, I'll drag this other program since it happens to be in here. This is a program that I use, and it's not really a template, but I use it to teach classes. And what it shows here is it's got a task for those of you who, again, who are in Siemens. The task is everything that includes all your separate programs. Siemens doesn't really have separate programs. Allen Bradley does. It allows you to have one continuous task with a whole bunch of programs in it. And that's what I've done here is I've created, just for teaching classes, I've created separate programs, and they all contain different kinds of things. Like this one here just has some examples in it and standard tools, filter. It has a little game in it, things like that. So it's not really machine related. This down here is actually sort of like a template, right? It is a machine template, and then this is a process control template. And I use it for classes because it shows two different ways of organizing the routines. Allen Bradley tends to put all their routines in alphabetical order, and so you have to put a letter in front of it if you want it to represent the order in which it was called. So I alphabetize things here, and then down here, I used a lowercase r with a number, right? And both of them would call their routines in this order. So if I go to the main routine, this doesn't even have any calls in it because I really didn't do anything with the process control. Let's see what this one does. I'm sure this one probably calls the routines because I have a fake machine in here. So you can see here that this set of jump to subroutine blocks here calls them in alphabetical order. So I had to put them in alphabetical order. Otherwise, they would show here in, you know, the lowest would probably be auto sequence assembly, and that's not what's called first, right? Auto sequence pick and place, auto sequence dial, all those things are called in that order. So that's why I alphabetize these. Same thing down here. So this is not really a template, but it does show, you know, what a full program would have in it. A bunch of UDTs, some add-on instructions, things like that. So one of the first things that I did when I started working on this particular template is I went into Automation NTH's programs, and I exported a whole bunch of their UDTs. You can see here that there are probably, well, about 100 of Automation NTH's UDTs. Now, some of these UDTs came from different places. Some of them came from that Sweet Machine that I showed you. Some of them came from their template, and some of them were in both. So you can see here that it looks like the people who wrote the program for the Sweet Machine may have used the original template and then created a whole lot of their own UDTs. And I can tell that a lot of these SPs, for instance, here are kind of process control things, right? Engineering values, get lot info. A lot of this has to do with processing of lot information, and they do have an ignition SCADA system, software system on there where they are gathering information, and they do shift configurations, they do OEE on this machine. So this would be all part of a typical template. You can see here a lot of robot things, recipe things, things that would be somewhat generic. And then there are some very specific things, and that I'm probably not going to put in my template necessarily. I would leave that up to somebody to import. Like, for instance, there is a lift and locate system that is just an in the conveyor lift system that lifts pallets up and locates the part on the pallet. Let's see what else we've got in here. Cameras, lift and locate, stops. I know there's stop, little pop-up stops. So there, I've alphabetized them here. Let's see, where is UDT? Stop should be in alphabetical order here. Stack light, there's one. Tooling. So a lot of these things are kind of generic. I don't see stop. I know there's a stop and a pre-stop. And then, of course, the other thing I did is I imported my own UDTs from that samples program and from American Beverage Depot, where I do some work. Now, some of these, I don't think I would ever use American Beverage Depot's batch data in a template, right? Unless I was building a template for American Beverage Depot, I might do that, but it would be doubtful because all of their machines don't use juice batches. So I would probably leave that up to the individual person to import that. So what else do you need here? You need EDS files. EDS files are the things that describe some of the components that are used in the template. So you can see here, I've got some SMC valve banks, pneumatic components. I've got some Cognex. These are both in add-on profiles. That's kind of the way that Allen Bradley does things now. They give you the add-on profile and it comes with the EDS files. So some of these are individual EDS files. Some of these this is a generic, right? A generic profile that I would have to build a generic device, and then I would populate that generic device with this data right here. So I have in the template that I'm working on right now, I have an Epson robot, and that's what I've done. I've put in the assembly instance and the size and what kind of data it is and that sort of thing. So you'll be seeing that in a moment. What else? We have the add-on profiles themselves. Once again, there are a bunch of them from NTH, Automation NTH, and from my own programs. You can see here, I've put the descriptions of my add-ons because I know what they do, whereas some of the NTH profiles, I don't really know what they do. So I didn't necessarily write down what they did. Digital input conditioning. This DI handler is one that I've used in previous classes. I have my own form of that just called DI, but I didn't even import that here. Now, what this is showing is that before I didn't really have a generic style of making an AOI name, but I've created one here. So what I've done is put a lowercase a, just like I put lowercase u's on my UDTs. Automation NTH's standard is that they will use the letters UDT, right? So that way I can tell it came from them. You'll see some inconsistencies every once in a while. This one here was all capitals. That's the way I exported it and ended up being all caps. Most of them are lowercase. So when I see something like that, all caps, I kind of assumed that possibly somebody else made it. It wasn't a standardized part. I used all caps here too myself before I had a real standard method of doing that. I even used the lowercase UDT here. This might have been from an NTH class. And then I've used lowercase u's for most of what I do lately. And I've started using, again, lowercase a's now. As I export things, you'll see that my add-on instructions that I exported, I renamed them with a lowercase a, and that's just for organizational purposes. Now, I would say these, I found all these uppercase T abbreviations, and I think these were made by Allen Bradley themselves. I can see clock sync versus NTP, daylight savings time. A lot of these have to do with time manipulation. If you want to find out if a date is earlier than another date, then you would do some math between two timestamps and determine which date was earlier or later. So that's where you see time greater than or equal to, time less than or equal to. I can kind of figure out what some of these things are. So it looks like most of these are time manipulation add-on instructions. So again, what is an add-on instruction? It is a little box where I can pass information into it, do something to that information, and pass other information out, like a Siemens function block. So like I said, I'll be teaching a class to their interns, and this time I really want to use some of their own add-on instructions, some of their own UDTs. But if I didn't give them this template, what would happen is they would spend the first day or two of the class just kind of getting their program set up. And that's just a kind of a waste of time. So I'm going to give them a head start by building this template. So I've kind of covered EDSs, right? These are device profiles, add-on instructions like function blocks, and UDTs, which are data structures. And again, I've got my own, and then I've got Automation NTHs. So let me show you where I'm at on my own template at this point. So this is a new template. I had an old template also, but I have created a new one here. This is the template that I'm building right now. So I built it sort of like the Sweet Machines program. For those of you who didn't know what the Sweet Machine was, and I don't have my book open right now, so I can't really show you all the information I created on that. Maybe that's another time where you can look at another webinar. So what this is their programs all have these routines in them. They have initialization. Their initialization is in structured text. It is not in ladder, but I've made mine in ladder because not all PLC programming software has the structured text add-on. That's one problem with it. So if I were doing a class and I was teaching somebody who doesn't use structured text, it would be better for this initialization routine to just be simple ladder. All initialization does is it puts initial values into things like resetting the machine. So when you power up a machine, maybe you do something like load recipe 1, load some timer values that are just basic timer values before an operator actually goes in and selects them. So that's what initialization type routines do. Pulse generator is something else they use. I usually put my own pulse generators in my system routine, which you can see here. I don't even have a system routine, so I'll probably create one here in just a moment. So their template has a whole system program. They have a base program. They have a robot program. And that is also what the Sweet Machine itself has in it. Sweet Machine also has a whole bunch more auto sequences, but I didn't import separate auto sequences for other things because that's really not part of a template, right? A template should just include the basics. If you have 3 or 4 auto sequences in your base routine, then you would add them yourself. And what this is it's giving you a hint that you should start your auto sequences in the R20 range. I don't know here why they didn't, for instance, use routine 20 itself. Maybe they left it open for the 10 series, right? They didn't use R10 either. So R11, R21, R41, I went ahead and made this template match that. Pulse generator inputs, auto sequence outputs. I've talked about this before in some of my PLC classes. It's very important that these get called in this order. You need to call your inputs, input conditioning, then do your auto sequences and your control, and then do your outputs. Some of these other things, some people put faults and events and things like that first. I tend to put mine after my outputs. It's not critical. The faults are going to rely on both the inputs and the outputs anyway. So I tend to put them afterward. It's just what I've always done. Another difference between my template and NTH's template, they put all of their faults in a routine called events. I don't like doing that because I can have a whole lot of data, that are not faults, right? Things like messages like hoppers are empty, refill this, or machine is running low, or upstream machine is not running, or something like that. So it's really important for me to differentiate between events and faults. So because I have a little bit of leeway, I'm able to teach this to their interns, and I'll just tell them, hey, your template is not going to have faults in it. It's going to all be under events. So I'll show them their program, and then I'll show them my template. But I will give them this template, and that's what they'll start with. Now, if I go to some of these routines, you'll see here that the routines are empty so far. They'll have to import their own information into the template. I'll show you what the regular input routine would look like. This is the samples program that I had before. And if I were to bring up a inputs routine, input conditioning, you know, e-stop is just the e-stop, right? And these are aliases for those of you who don't know Alan Bradley. An alias is simply a link to another address. So this e-stop push button is linked to something called digital input card 1.8. It would normally be linked to a physical address, but since I use a simulator here, I link it to just a simulated input card. And I use this again for my book material too. This is a more typical case of input conditioning. So if the grippers are open, then right, this would have to be on and this would have to be off. And that would signify that the grippers are open, right? So toggle bit, and this one couldn't be on. So that's what input conditioning is all about. So I would expect people to put this kind of code in their own template, right? If I go here, you'll see that I don't have anything in the inputs routine, but I'm going to put something in here to kind of show you how this works. Because again, this is a template, and this is a template that uses these addresses, as I mentioned before. They have an add-on here called DI Handler, and that is digital input conditioning. Digital input conditioning is just like what I put here, right? It's just like this, except you can pass these variables into the DI handler and it will pass this out. So this is just like in a function block in Siemens. I pass in these two variables, I pass out this variable, and I would also have, if I were doing something like a photo eye, I might have a timer, right? So this is a part present photo eye, and often people do what's called debouncing of a photo eye. Well, this DI handler has that built in. So I'm going to go ahead and put one of those in there. So I'm going to open the inputs routine, and you'll see that there's nothing in there right now. And I'm going to call up this add-on profile. And the add-on profile, one of the bad things about this is you can't read these, right? The full thing here, but DI handler is in here. It's right here. So this is a block that you would pass a raw input into. You could force it on or off. So that's what their logic does here. It conditions the input, and then there's an on delay timer, an off delay timer, and there is the ability to invert the signal. And then you would pass out the variable, and that would end up in here. Let's see. So you'd have to make a tag, and I'm going to call this sample input, and it will create the tag. And this is another thing that would be typically done in a template, is you would go ahead and create some generic addresses, and then people would have to delete them or change their names or whatever if they wanted to create them. Now this one here, because of the way that add-on instructions work, the data type is going to be this add-on instruction, DI handler. And all I need to do is say, create it. I can put a comment in here if I want to, and I might want to put something like delete this after you, if not using, right? Because it's just a sample, it's a placeholder. I would pass in some kind of a raw input. Now I'm going to show you a little more on this template that I've put in here. I mentioned all those EDS files. Part of this template, this is the hardware, and I've really put a lot of crazy hardware in here. This has a basic safety PLC in it, and the reason again that I use the safety PLC, I'm going to go ahead and show you this again. This is based on this machine, this base, and this base used a safety PLC. And so I am again building this template based on the program at NTH that used this, and it had a lot of these things in it. So if I go up here, again, there is a safety PLC itself. There is a point IO module, 3 of which modules are safety modules. So this is a safety input module, safety input module, safety output module. What those are is those are dual channel modules for things like e-stops. So when I go to my program, you will see that all the logic for the e-stops will be right here. So dual channel e-stops, dual channel guard doors, dual channel relays. This is a category 3 safety machine. So it's got a lot of safety stuff on it. I want to say it had 8 to 10 safety inputs in that little Sweet Machine. And that's to stop people from getting hurt, right? So it's got safety control even for the robot. So if somebody hits the e-stop, it pulls the power from the safety relays and drops the power to things safely. So that safety task reflects a lot of that. And that works hand in hand with this safety capable PLC. And for Allen Bradley, they put just a little bit of red in here. And that's kind of how you know it's a safety device. So what else did I put in here? I put 2 valve banks. These once again came from these EDS files. If I were to give somebody this program and just hand them the program and they didn't have these EDS files that I had also had to give them, and they are not imported in here. They have to be on people's PLC already. So they're going to have to import the EDS files, and this is a list of all the EDS files that are available, and you'd have to go import them. Here is a list of all the add-ons again that I've used in here, including DI handler. Here's a list of the UDTs. So if you can have the UDTs as part of the template, and you don't have to import it, but the EDS files, there's no alternative but to go up here. And if I go to tools, there's a thing called a hardware installation tool for EDS files. And I'm going to bring it up here. We'll see what it looks like. Hopefully it'll pop up. There we go. So next, register an EDS file. What this does is you go find your EDS files, bring them in, and so what I've done here is I've kind of organized things as a bunch of template files. And let's see here. Where did I put it? There we go. PLC tech files. I reorganized this. And again, you can find all these EDS files. So if I wanted to put a Keyence, right, Keyence CVX camera, which I might do that. I'll go ahead and do that. So open. There it is. And I have now installed this Keyence camera system to be available. There we go, finish. And now I could choose if I wanted to add a device. I'd go to my Ethernet. And I'm not going to probably actually add this device because I've already got a whole ton of devices already here. New module, but I'm going to show you kind of how it's done. Since this all goes on YouTube, it's kind of handy. So you can see here, these are all the things that are available for me to add to this program. And it alphabetizes them, and you can see this one's new, right? So Keyence devices, and you have the ability to add any of these devices, but you have to import them first. Again, for those of you who are Siemens people, this is the same as your GSD files, which are generic system description files, right? So you can see here, you can now select this. If you did that, you would have to do more or less the same things that I did here, which is this valve bank has an IP address, 10.2.4.30. Here's 10.2.4.31. This point IO module is 20, 30, 31, 40, the IO link master. I had to import that. That's a GSD file. They use a lot of IO link at Automation NTH. So I went ahead and put it in here. Here's an Epson robot. And this is where, so I'm going to open this up, right? So this information here, if I have a generic device and they don't have an EDS file, I can drop a device in there, mention the inputs, the outputs, the instance, all this stuff, put the IP address on it, right? Talk about how fast it needs to communicate. So every 10 milliseconds. And all that information, again, if you didn't have this, you would have a hard time in your template building it. So where I put EDS file, I said, if you're using an Epson robot, fill out your information like this. And they had another robot in another program that was a Stäubli robot, which is a German robot, and it had a completely different set of parameters set up for it. There's a guy named Tony Martin at NTH who's a robot expert, and he uses a lot of Stäubli instead of Epson. So same thing with GE Fanuc, except for instance, GE Fanuc already has its own EDS file, right? Communication adapter for a Fanuc robot here. Now this one, I'm going to tell you, if you had to get this, you can't just go online and find it. You have to call Fanuc up and they're going to ask you for your serial number. So that's a kind of an inconvenient thing about dealing with Fanuc. You can't just download it. I've dealt with things like Motoman before, and I just go to their website and they allow me to download it. But Fanuc really wants more information than that. So anyway, these are all generic devices that I've pulled in here. Now, what I'm doing with this template, again, is I'm going to be teaching a class with it. So I want all the things that they could possibly use in the class, including I've put some things like simulated inputs. Here's all the regular inputs, right? If I want to do point IO card number 5, let's see, point IO card number 4, there we go. There is the data, input data for this fault, right? You can tell all kinds of things physically about all your data here, but I made some fake data, and that is simulated digital input, simulated digital output, since I'm going to use this and download it to a simulator, right? Template PLC, and I'll have to reconfigure this. This won't be this safety PLC anymore. It'll have to be configured as a simulator. So here's an example of that. This was the sample program I showed you before. If I go to the hardware down here, it says emulate 5570 samples, right? So it's a different processor and it's got physical cards with it and everything. And I can download this straight into the emulator. That's it. It says up here, emulate 5570. So this one here, because it's a template, will not be configured as a simulator. What I'll do is I'll save the template. It'll be called template PLC, but I'll save it as, for instance, simulate ALLC PLC, and then reassign the processor as an emulator, like I did in the other one. But anyway, so the point of doing this template is so that somebody has a place to start their program, right? They will already have all of the routines set up. The routines may be empty, or they may include some simple code in it, right, that gives somebody a start for an auto sequence. It may have step 0, step 10, something like that, and then maybe the final step in the auto sequence. It may have one sample output rung that would look like one of these output rungs. We'll bring one up here. Input conditioning outputs. So you can see here that most of these output rungs look pretty much the same. Grippers closed. Almost all programmers are going to program something like this. You're going to have an output, physical output, some kind of a permissive or an interlock. People call them interlocks sometimes. Then they're going to have auto mode and the thing that makes it go in auto mode. And then they're going to have manual mode and usually a push button, right? So in my case, I just generically assign this to memory bit something. So I could take this and I could say auto mode, sample output command, sample auto command, sample permissive, sample output, and then somebody could copy this and they could substitute tags for it over and over again, right? And this is the kind of thing that I would put, again, back in this template. Now in this template, I just started this recently. I have a next week entirely to work on this. So I haven't got anything in here yet. If I go outputs, you can see it's an empty routine. But what would I put in here? I would put a sample, and I would probably put some instructions saying, this is the way I want you to use these outputs. I want you to structure it like this. In the auto sequence, I would say I want you to build your auto sequence like this. We're going to use numerical sequences, for instance. A numerical sequence looks like auto sequence pick and place. Here's a pick and place sequence. That's a numerical sequence. It goes, oh, this is actually a bit sequence. So I did a bit sequence on this one. I'm sure I did a word sequence somewhere else. Well, here's bits too. I usually use word sequences. See what this one looks like. Ah, there we go. So here is a word sequence. This is probably what some people are more used to. 0, if this happens, move a 10. If this happens, and if I'm at 10 and this happens and I'm in auto cycle, move a 20. If I'm in 20 and this happens, move a 30, right? So this is a typical numerical auto sequence. These are bit sequences, right? So step 3, step 4, if it's more or less the same concept. If I'm in 3 but not in 4, then this happens and latch 4. If I'm in 4 and not in 5, then this happens and latch 5. And you go step by step, and then you come down to the bottom and you have a register or state type, and auto sequence state. So this works pretty well. That's for assembly. Let's look what this one looks like. So I'm getting off track here a little bit. This is not really part of the template. This is part of the samples, but this is the kind of stuff that I would put in my template right here. I would put this auto sequence stuff in here after, again, importing things like these. You can see here, I've already imported my add-on instructions. Each of these add-on instructions have their own code inside. As a matter of fact, here is the DI handler. I'll show you what that looks like. This was the input conditioning, where you pass in information, right? You can run timers with it, things like that, put a preset in there, and then you get a value. And the value is what Automation NTH uses as a generic name. So this would be, you know, if I made this sample input, which I believe is what I did name it, sample input, then it would be sample input dot value. And that would be the output for this DI handler device. And so all they need to do as part of their template is copy this and put all the inputs, the physical inputs that they want to use. Again, because it's Allen Bradley, they would probably alias them to physical inputs, and they would have the name of something like cylinder extended procs. Cylinder extended procs alias to a physical input, and then pass out input dot value. And that's the way their template would work. So what else have I imported here? Bunch of UDTs. This one is a somewhat complex UDT base configuration. And again, this comes from NTH, so you can see that they abbreviate all their UDTs as UDT underscore. I abbreviate my UDTs as U underscore. So that way you can tell the difference between my UDTs and their UDTs. This configuration, because this base is this base right here, right? This base, it has the elevators on it. It's got a left elevator and a right elevator. So their base configuration is that, right? It's got a left elevator, a right elevator, and HMI. And what they do is they say, if you are using a left elevator, then you would put a 1 in this. Config left elevator, yes. Config right elevator, yes, right? So you would click those two if you were using those, and that would pre-configure your base. Now, in my template, I would not typically use a base because I don't have a base, right? My machinery, every machine's different. I work on bottling machines and automotive machines and presses and oil and gas sometimes, so all my machines are somewhat different. So it wouldn't make a lot of sense for me to have a UDT base configuration in my generic template. But if I'm teaching a class to Automation NTH, if their template's supposed to have it in it, then once again, I give them the capability of browsing all of these files and importing the AOIs that they would need, or the UDTs that they would need. And they have 110 of them here, right? So NTH has tons and tons of UDTs from all these different programs. This suite is that machine that you saw there. That's the Sweet Machine. So that's where I got that stuff from when I exported it. And then of course I have my own stuff down here. This one's from ABD's. They're a beverage manufacturer, and these are generic UDTs that I used in my samples program. Okay, I'm going to show you something else really fun here. This goes back a way, and I mentioned that this was going to be a somewhat complicated webinar today, that I'm going to be talking about a lot of strange things that you may not be familiar with. So this is a template IO generator. And what this does, you can see here that there are some buttons in here that run macros in this Excel spreadsheet that actually generate lists of tags and things like that, and also actually generates code. So Alan Bradley, I'll go ahead and show you how Alan Bradley's text version of code looks. We'll do this here. But there is a text in any PLC program, doesn't matter what brand it is, there's always a text version of code. So this one here, you can see that's a picture, that's ladder logic, and it says burner, solenoid valve, auto mode, auto burn control. If I double click this wrong, I get this text right up here. This text is a ASCII version, and that's what Alan Bradley calls this, of this rung, right? So it says branch start, examine if closed, which is Alan Bradley's terminology for a normally open contact. Examine if closed, auto mode. Examine if closed, auto burn control. Next branch, right? NXB is next branch, goes down to this one. Then it says XIC, right? Examine if closed, manual mode. Examine if closed, burn test, HMI push button. Branch end. Then XIC burner control, permissive, and OTE, which is just a coil burner solenoid valve. So this is the text version of this rung. And this generates that code. Okay, so if I push this button, it says generate all files, or IO list indicator, or PLC code and tag, I can push any one of these buttons and it will create different things. Now, how does it do that? Let's see if we can get where we see the whole thing. There are a whole lot of tabs in here. There's some revision information in here. This is all the way back in 2005, 2006. That's when this era is from. And what it does, this is kind of the heart of the code. So you populate, right, miscellaneous markers, things like that. This has to do with AutoCAD. You can put some notes in here if you want to. You can put device abbreviation here, digital input, guard door switch, control relay. And what it does is it takes this text and it generates first, here's the description. This description would go in the AutoCAD file, right? Zone 1. This would be the comment also in your PLC. This would be the AutoCAD file here. So dial indexer, alias tag name start. Actually, this is not the, see if I can find it. Full description. Where is the AutoCAD file? I know it's in here. Oh, there we go. AutoCAD description. So AutoCAD has fixed lengths for fields, right? So the fixed lengths would be inspection dial, then the second line would be encoder, third line would be, you know, GDS tester 1, fourth line would be open. So you're limited when you go into these, and this has to be formatted to be in this order. And then what this does is it makes sure that this full description, that goes on the HMI is a single line. So this is the AutoCAD files. This is the PLC description files, and they're linked together. And so by using a single spreadsheet like this, you're getting your AutoCAD descriptions, your HMI descriptions, your PLC descriptions, all in the same spreadsheet. AutoCAD wire label, right? There's the physical address, PLC address. This is in the format that Alan Bradley likes it. This is the input and output alias tag, right? With I, this is what Wright Industries was, which is where I used to work. This is what they used. They used an I in the middle. This is their status. So that DI handler that you saw, this would have been the value that you passed into the DI handler. This would have been the value that you got out of the DI handler. And that's for inputs. Now, if you do outputs, it knows, because you've configured back here that it was an output, it knows to stick an O in here and to stick a permissive, right? Output permissive. So it doesn't do input structures for outputs. It only does output structures. So this was a really good time saver for generating templates. It also created this, and this was for panel view pluses. And a panel view plus had a structure like this. If I were to take my panel view plus push buttons and items on the screen and export them, they would be exported like this. This zero fill would say, okay, I don't want a bunch of empty space after the name of this message or whatever. And the background color would be navy blue, and it would be a transparent back style and all that kind of stuff. So this spreadsheet saves a ton of time. By putting in your addresses and your descriptions and things one time, it creates the AutoCAD files, it creates the PLC tags that get imported into the controller tags, it creates the HMI tags that you import into the HMI, right? And then also things like your fault messages. Every output is going to have a fault. That's pretty much the way all PLC programs work. If an output doesn't fire, unless it's something like a stack light. Stack light's not particularly, it's not going to have a fault associated with a stack light. It failed to light. You don't even know if it failed to light, right? But a solenoid valve, if I fire a solenoid valve and I don't hit an input within a certain period of time, I create a fault. Well, I'm going to have some kind of a fault message that needs to pop up. I'm also going to have some kind of fault logic, right? That's going to pop up. And even back here, 15 years ago, we were doing time, counts for every fault. We could log how many faults have I had, what time was it, etc. So this was an old spreadsheet that I did all that with years ago. Lots of abbreviations, lots of help on this. And I am now creating a new spreadsheet. And this new spreadsheet it's not as big as that one yet, but it's a little bit smarter than that one is. So what I'm doing in here is more or less the same thing. Let's see if I can find this. Looks like Samarjit is here. Let me see what you said. Sir, can you explain about encoder input setup? Well, okay, that's a sort of a different topic, but since there's only two of us here, I'll explain the basic idea for that. Now, are you talking about Alan Bradley, or are you talking about another brand? Okay, so encoders, of course, what an encoder does is it feeds into a special card called a high-speed counter card. And again, it would be different if you were using the old 500 platform, or if you were using the 5000 platform. But either way, you would have to set the card up to take the inputs from the encoder. The encoder has three types of pulses. It has A pulses, it has B pulses, and it has a Z pulse. A Z pulse is sometimes called a marker pulse. Your encoder, you're going to have to put things like how many pulses per revolution that encoder is. And what the high-speed counter card does is it counts faster than the PLC can recognize physical inputs, right? A physical input, maybe I can pick it up in a couple milliseconds for one input, but with an encoder, I'm getting thousands of inputs in less than a second. So the encoder card has to accumulate those pulses and then report them back to the PLC. So every card's different, right? And here, so I hear you saying something there, Samarjit, but let me see if I.
Hello, are you here, sir?
Yeah, I'm here. Yeah.
So actually, I know what is about everything about encoder because I'm using on Delta some brand. I'm using encoder on Fatek brand, but I never use an encoder on Allen Bradley PLC. So that's I want to learn about.
Well, it would take longer than we have left in here to fully explain it, but the basic idea would be, and I'll use this one. I'll add a card here. We'll see if we can find an encoder card.
Okay.
Okay, so 1756, that's my family here. So I would have to, and it's probably going to be something like a 1756 HSC. There we go, high-speed counter. So I'm going to create that. Since this is just a simulation, it doesn't really matter which brand I use. And I'll call this palletizer. So that would be the encoder inputs, and I'm going to put it in a slot here, and we'll put it in slot 8. High-speed counter data. Okay, so now you have the properties itself. This is how often the card is going to report back to the processor. Then the counter configuration itself, you have a bunch of different modes that you can use here. When you do, and I don't have a way to kind of show this because I don't have anything prepared, but the X1 mode is 1 count per pulse, right? So that means on the positive and the negative wave, I would get 1 count. If I use encoder X4 mode, I get 1 on the rising edge, 1 on the falling edge, right? So I get 4 times as many counts because there's a, for a single pulse, because there's 4 events there. Frequency mode, I'm just going to get the frequency. How fast is it running? Which most people use resolvers for that. So there's a bunch of different modes. Most people use these in counter mode, right? It just counts. Storage mode, I can store and continue the values, which means if I powered off the encoder, it would remember in the logic where it was at and not reset, right? Store, wait, and reserve. You're going to have to look up all these because these are all in the help files, right? But that's the basic idea here. And store and continue, I've used that kind of thing before. Rollover, I could say at 10,000 pulses, I want it to roll over and go to 0. I could say at 1 million pulses, I want it to roll over and go to 0. There's your 3 pulses I was telling you about, the A, B, and Z, right? There's 1 Z pulse per full revolution in the encoder, and there's whatever your count is. If I have 1,000 pulse per revolution encoder, then I have 1,000 A pulses, I have 1,000 B pulses, and they're offset by 90 degrees. So if A leads B, it's moving in one direction. If B leads A, it's moving the other direction. So that's how I know bidirectional counts. That's where the 4 events come from, right? I have 1 rising A, 1 rising B, 1 falling A, and 1 falling B. And that's the X4 mode I was talking about, right? So encoder X4, I would get 1 pulse on the rising A, 1 pulse on the rising B, 1 pulse on the falling A, etc. Period rate, frequency, you'll have to look up what all those are, but basically you can tell the difference. This is more of a how fast is something moving. This is a count. Counter mode is a lot of times what I use. Output configuration, I have 4 outputs here, and I can tie the output to fire at a specific count. So if I had something like 15,000 counts, I want this output to come on. That's going to be faster than taking the count, passing it back to the processor, and then firing a processor output. So since this is built right into the card, then that is how I would tie it in there. So I can pick output tied to counter 0. When I get this count, it is going to happen immediately. And then I can set up times and all kinds of things, make it pulse, however I want to do it. I can make it come on at a certain count, and I believe I can turn it off at another count. So I could set it, go on at 15,000, go off at 16,000. Right, so I'd set my encoder up to take this first value output 0, and do that. There's a lot to this. Like I said, this is more than we really have time for today. Today I had, mostly planned on just doing this, but I can control all kinds of things for this. I can set this up however I wanted to. So if I say okay, that's now saved. That's my slot 8 palletizer encoder output. I would wire my encoder into it. There's kind of a lot of tricks to this. There's tricks on the wiring. Sometimes you have to use line drivers, all kinds of things. If you were online live, you would see the actual condition of the card here. Again, there's where you configure the card. You can filter things. You can scale the outputs. You can invert the Z, all kinds of things. And then if I go to slot 8, I'll show you where that is. By adding this card, if I go into the controller tags, you should be able to see local slot 8. Local 6. There we go. So because I just added it, it put it down here. So if I say local inputs, there is the current value of the counter, right? Present value. So as it counts, I would see it count here. And I could say, for instance, turn on an output if this present value was over a certain value, but you really don't want to do that because it's slower than using the physical output from the card itself. So people usually use it, an encoder input for 2 reasons. 1, it counts much, much faster than the PLC can. And 2, you can fire your output immediately rather than passing it to the PLC, waiting for the scan time, and then putting the output out that way. So hopefully that answers your question.
Oh, thank you, sir. Hello?
I actually, on YouTube, I believe I had another, it wasn't a webinar, but I put something in there on motion control and encoders about a year ago, maybe a year and a half ago. So I don't remember exactly what I put on there, but I did put a motion control encoder thing on there. So you can kind of add this to that, and it more or less works the same way.
Okay, thank you, sir.
Okay, no problem. So anyway, today's this is more or less the end of this this webinar today. Again, I hope people got what they wanted to out of this template kind of thing here. What this should show you here, right? All this stuff here is that there's a lot of power into creating a spreadsheet that automatically concatenates names and allows you to import them into the program. So building the template itself, you're going to need a lot of information. To recap, you're going to need add-on instructions. You're going to need EDS files, lots of EDS files. You're going to need UDTs, lots of UDTs. You're going to have to import them in there, and you will build a pre-done program. As I mentioned, it's a basic PLC program that serves as a starting point, saving development time, and this includes all these devices, also includes basic routines. And so that's what I'm setting up here for this class that I'm about to teach. I've got about 2 weeks till I teach the class, but one of those weeks I'm up in Maryland, in Baltimore, so I won't even be working on this. So I have basically next week to prepare my template for this class, and this is the basic program that they will use to write their own program. And again, I'm doing it using Automation NTH's basic setup. That's the whole purpose behind this. The next webinar is in about 2 weeks. Again, it will be the day after I get back from Baltimore. So that week, I'm not going to have a lot of time to prepare. I do not have a guest. I do not have a topic. I may continue on this PLC stuff. Again, it's on a Saturday. A lot of people don't show up on Saturday. Last Saturday, we had 2 or 3 people show up, or 2 weeks ago. This Saturday, Samarjit, thanks for showing up. But yeah, we don't get a lot of people on Saturdays. I don't prefer to do it on Saturdays either, but a lot of times I'm busy on Friday, so I can't do the webinar if I'm traveling and things like that. So anyway, that is the end of the webinar. Hope everybody enjoyed it, and we'll see you the next time.